Hello friends, in this video we'll learn how to solve an assignment problem which is of maximization type and is also unbalanced. So we have an assignment problem. Here we have jobs and 5 machines, and you can see that it is a maximization problem, and we have 4 jobs and 5 machines. That's why it is unbalanced problem. So first of all we need to convert this problem into a minimization type problem. To convert it into a minimization type problem, we have subtracted all the entries of this cost matrix from the largest element of the cost matrix. The largest element of the cost matrix is 111, so we have subtracted it like 111 minus 62, that is 49, 111 minus 78 is equal to 33, 111 minus 50, that is equal to 61. Similarly, we have subtracted all the entries from 111 to obtain this resulting matrix. Now it is also an unbalanced problem. To convert it into the balanced problem, we will introduce an dummy variable. Now you can see, to make it a balanced type problem, we have introduced a fifth job, and that is a dummy variable, and the cost associated with each assignment of the fifth job is 0. Now we will subtract the minimum element of each row from all the other elements of that respective row. So now you can see here that the minimum element of row first is 10, and we have subtracted it like 49 minus 10 39, 33 minus 10 23, 61 minus 10 51, 10 minus 10 0, and 29 minus 10 19. And the minimum element of the second row is 27, and we have did it like 40 minus 27 13, 27 minus 27 0, 50 minus 27 23, 38 minus 27 11, and 52 minus 27 25. Similarly, we have did it for other two rows, and the fifth row will remain contain whole zeros. And now again, when we'll do it for the columns, you'll see that each column contains at least one zero, so the transformation for columns will remain same as that of the rows. So now you can see for the columns that the previous cost matrix has remained unchanged. So now we will draw the horizontal and vertical lines to cover up all the zeros. So now you can see that we needed only four lines to cover up all the zeros, but it is not equal to the order of the matrix, which is 5. So we can say that the optimum assignment cannot be made in this cost matrix. So now we will we'll have to look for the minimum element which is not covered by the lines, and subtract this element from all the entries of the matrix which are not covered by the lines, and add that element to the entries which lies at the intersection of the lines. And also elements covered with the lines remain same except for those which lies at the intersection, and the resulting matrix would look like. Here you can see that the minimum element which was uncovered was 7, and we have subtracted that element from the uncovered elements and also added 7 to the elements which are at the intersection, like here, here, here and here. So this is the resulting cost matrix, and now again we'll have to draw vertical and horizontal lines to cover up all the zeros. So now you can see that we needed 5 lines to cover up all the zeros, and which is equal to the order of the matrix, that is 5. So we can say that an optimum assignment can be made. So now to make optimum assignments, we'll include all the zeros from this matrix and we leave all the non-zero elements. Now to make the optimum assignment, we'll look for the column or the row which contain exactly 1 0. So like the first column contains exactly 1 0, so we'll assign the fifth job to machine A. And we'll cross these zeros so that this job cannot be assigned to any other machine. And now we can see that the column B contains exactly 1 0, so we'll assign job 2 to the machine B. Now we see that the fifth column contains exactly 1 0, so we'll assign the job 4 to the machine E, and we'll cut this 0 so that this job cannot be assigned to C. And now we can assign the job third to the machine C, and the remaining job 1 will be assigned to machine D. So now these are the optimum assignment, like job 1 has been assigned to machine D, second to B, third to C, fourth to E and fifth to A. And the result fifth to A assignment should be declined, as the job fifth was introduced using a dummy variable and it was a fake job. And now to calculate the maximum profit, we will look for the corresponding elements to these assignments. Like this assignment corresponds to the value 101. This assignment corresponds to the value 84. This assignment corresponds to the value 111, and this assignment corresponds to the value 80. So the maximum profit will be 376. So this is our solution, assignments and the maximum profit. If you find this video helpful, you can press the like button, subscribe my channel, or may leave a comment. Thank you for watching. Happy learning.